Welcome back. Myself Fazana. In last session, we are done with data loading and data preparation for multi-class classification. If not yet watched the session, please do check. The link will be highlighted as well. Now we are going to talk about the modeling part. Post this, we check what's the best practice to improve the performance. We are aware there are two ways to program. One is sequential, the other is modular. Currently we start with sequential approach. Ultimately we want to switch it into modular approach in later part. The reason is which is more dynamic, we can customize and mold it. If you are confused how to start or to build the model, let's start with LeanIt, which is one of the simplest architecture to start with. We will keep this as the starting point. We build the model and later we make the changes based on the performance. So initially we follow with the LeanIt architecture. So we want to start with convolution, follow up with pooling, convolution pooling, then flatten, then with add dense layer, then finally with the output layer. Before we dive for today's session, if not to subscribe my channel, please do support by subscribing. If already subscribed, please hit the bell button so we will not miss the next video, and don't forget to hit like and share. Now, are you ready to build the model? Let's start with importing the necessary libraries for today's session. Is from TensorFlow.keras we are going to import models and layers. From TensorFlow.keras.utils we import plot_model. First step is to create a sequential model. So I'm passing model equal to models.sequential. Think like it is an empty neural network which has no layer in it. Going forward we will add layers to it. The next step is to add the convolution block. Whenever we use a sequential model, first layer should contain input shape. So here our input shape is 28 of 28 of 1, then activation is ReLU, filter 6 and kernel size is 3 of 3, which means each filter of size 3 by 3. The number of filter and the size of filters are hyperparameter. The next step is to add the max pooling layer. Here our pool size is here our pool size is 2 of 2, and next step is to add the second convolution block. Here it is not necessary to pass the input shape, it is mandatory only in the first layer. Then again we are going to add the max pool layer. So till here we done with 2 blocks of feature extraction. Next step is to add the flatten layer. So here model.add layers.flatten. So what is the use of a flatten? It will convert matrix into array format, which means if I have a matrix of 3 by 3 means it will convert it into 1 by 9. If it is of 5 by 5 means it will convert it into 1 by 25. So this is the transit from feature extraction to classification. After flatten, now the next step is the classification of job. At the end we add output layer. Here I added 2 dense layer with neurons 120 and 84. The reason is why? Because in LeanIt it's followed with 120 and 84. So there is nothing reason behind it. Just we are following the LeanIt architecture. So the dense layer just the job of classification. It acts as fully connected layer as we discussed in our convolutional neural session. So there are 2 important components in convolutional neural network is feature extraction and classification. Then the final step is to add the output layer. Here why we pass 10? It's a 10 class classification. So the number of neurons should be exactly equal to class, and activation here is softmax. The reason we used multi-class classification, so it is a softmax. If it is for 2 class, we will go for sigmoid. Softmax gives probability and sum of all probability gives 1. So the neuron which gets highest probability will be the right class. Let me execute this one and make sure that enable the GPU from kernel. To do that, just click this accelerated part. So select GPU, that's it. Next step is I am going to display this model. For that pass plot_model, then our model name is model. Here it is our model name, this is model. I am just going to pass this. So here input layer followed with the convolution, max pool convolution, max pool, then flatten, then finally our dense layer, then followed with the output layer. The next step is to compile the model. Let me execute this one. Adam is a very good optimizer to start with. When we use the softmax in output layer, we use categorical cross entropy as a loss. If sigmoid, we should use binary cross entropy. So these are all the hyperparameter we use as a part of compiling the processor. Then the next step is model.summary. So now we will analyze the computation for this parameters. Okay. See, initially our input shape is of 28 of 28. Okay, now see, now it got reduced to 26 of 26, and here our filter is 6. So shape is 3 by 3, which is equal to 9. So 9 into 6, which is equal to 54. So for each filter we have a bias. So for 6 filter we have 6 bias. So 54 plus 6, which is equal to 60. So this is how 60 got calculated. For max pooling we don't have any computation. Then again with the convolution 2, here we use 10 filter. So 10 into 9, which is equal to 90. If we connect with the previous layer, then 90 into 6, which is equal to 540. So 10 filters, so we have 10 bias. So 550. So this is how it got calculated. Then again max pooling, again we don't have computation. The next step is flatten. So here we have 5 into 5 into 10, so which is equal to 250. How it comes? 5 into 5 into 10. So this is how it converted matrix into array. For this we have 250 into 120 plus 120 bias. Okay, so it got calculated to 30,120. So totally we have 41,744 weights plus bias. So this is how it got calculated. So this is the explanation for this model.summary. We can increase the hidden layer as many as we want. More the hidden layer will be more powerful, but there is a chance of overfit. So make sure this point to get considered. Number of hidden layer, convolution layer, max pool layer, all these are hyperparameter. Now the next step is to train the model. Let me execute this step. So here the batch size is 1000. As we took the batch size is 1000, it comes up with 16 iteration. And our epoch is equal to 20. So it will go up till 20. Verbose is equal to true, and then validation data I'm passing X test and Y test. Now this step is done, and we found that the accuracy is 88 and then validation accuracy is 87. So this is not that powerful model. It's like overfit. The reason is validation accuracy is more than this accuracy. So when we are not happy with this, we can go and change the performance of the model. But the question here, can we go and change the model by seeing the accuracy? Answer is no. We should not only consider just this accuracy and then the validation accuracy. To validate the performance, validation accuracy and training accuracy is not only the option. So now we jump to performance analysis. Let me execute this one. To do this, I am converting Vipred. Initially it is not a one hot encoder, so I am converting. So then I am passing this value to Vipred to categorical of this Vipred. Now let's see what's the challenge, why this model is not that good in performance. To understand that, let me execute this classification report. By seeing this, class 4 is with 0.75 and class 6 is 0.63, which is very poor, right? So this is the challenging. So we can say that by seeing this classification report, instead of optimizing the architecture, can we go with optimize the data? Reason here is we have challenges only with two classes. So it may be a data quality or quantity. The reason is other classes seems to be good. Only we have challenges with the two classes, one with class 4, the other one is with class 6. So to further explore on this, we are going to use confusion matrix. So we'll display the confusion matrix now. By seeing this graph, we can get an idea whether it is a quality issue or quantity issue. Can you guess what? It is a quality or quantity? It's a quality issue. How? See here, the t-shirt correctly found as 747, but in shirt it is also identified as 184 instead of t-shirt it identified as shirt. Again we come and check with shirt, okay now. So for shirt and with shirt it found right one with the 698, but coat, dress, pullover, t-shirt, okay now, it found as a wrong, which is not equal to shirt. So this is a quality issue. So the question is, how can you tell that this is a quality issue? See example, if there is an issue with an ankle boot and shirt, means we can clearly say that it is a quantity issue. But now the issue with shirt and t-shirt, so it falls with the quality issue. Now, how to optimize versus quantity and versus quantity. Whenever we go and change architecture, we should not change blindly. So, randomly increasing or decreasing is not a suitable approach, which will tend to an overfit or underfit. That we want to analyze in detail. So, if quality, what to do? If quantity, what to do? What type of changes to be done in our model? So, this is what we are going to discuss in next session. I hope you like the content. If you found the content is informative, do like, share and subscribe. Catch you soon in the next session. Till then, Pradana signing off.